Today we're going to take a look at sets and how sets are going to be used in our application problems this week. We're going to take a look at the notation and some example problems to make sure that you're fully prepared for this week's assignment. So first thing we need to know is the notation for a set is that we list elements with this squiggle bracket that's found above the enter button. It's very specific. When I'm grading your weekly application problems, I need to see that bracket there. I can't see parentheses or a solid square bracket. We need to see those squiggle brackets. There needs to be a comma between each item that's listed in the set. So an example of this would be if I wanted to list a set of odd numbers from 1 to 10 in what we call an element list, I would list them out with the bracket 1, 3, 5, 7, 9, close bracket. So notice there's a comma between each of those, and that's just like in English when we start learning grammar, there's specific grammar rules. The same rule applies here for sets, so I don't confuse this with a point in the coordinate plane or other things that have notation similar to this. Now, when we talk about elements, we're talking about the items within the set. So that would be the 1, 3, 5, 7, 9 in the previous example. What we use to say something is in a set is this sideways curvy E. What that's read as is an element of. So if I have P element A, I would read it as the pillow is an element of A. So an example from what you're going to see in the application problems would be, is it true, false, given that A equals this list of elements? Is 2 an element of A? So I go into A. Do I see the number 2? Yes, I do. So then it's true. 2 is an element that is located in set A. If 2 is not found in set A, it would be false. So the next two notations we have is what we call an intersection and what we call a union. When we're doing a union, we're combining every element in two sets into one larger set. So when the union symbol that I use would be the U-type character, the upside down would be this U upside right character. If I want to take what's common in two sets, that would be the intersection. So that's going to be a smaller group. The intersection, or the upside down U, is going to be all the things that are in both sets. So if I'm given set C and set D here, and I want to find the union of that set, I'm going to create a new set that has every element that's located in both. Now, I want you to notice 4 is in C and 4 is in D, but I only wrote it one time. This is very important as we get to cardinality. You only write an element once, even if it's located in both sets. So a union is always a larger set that has every element in both. An intersection means I would go through the list and see what they have in common. D doesn't have a 1, D doesn't have a 2, D has a 4, a 5, and a 6. So that would be the intersection. So intersection is what they have in common, and union is when I put them both together. So here's a practice problem. What would the intersection of A, being that X is odd, so all odd numbers, and B says X is between -4 and 6. So I want to know what are the elements. So remember, intersection is what they have in common. So if I'm looking for the intersection here, I want things that are in both sets. So I can list out both sets, or I can list out B, which is the smaller set, which is my recommendation. So I listed out everything between -4 and +6. And then I'm going to go through this list and I'm going to say who is odd. -3 is odd, the sign doesn't matter. -1 is odd, 1, and remember 0 is neither odd nor even. 3 and 5. So here is my answer. So it's really helpful when you list things out so that you're able to really see what they have in common. Now I'm asking you, what is the union of the set of A, natural numbers between 4 and 8, and single-digit negative integers? So once again, I'm going to list things out. The numbers between 4 and 8 would be 4, 5, 6, 7, 8. My negative single-digit numbers would be -9 to -1. Remember, 0 is neither positive nor negative. Because it's a union, I'm taking everything in B and everything in A and combining them into one larger set. So you really shouldn't have much problem with the notation this week and typing this in for your homework, because you're going to be using things that are on your keyboard. Now for a subset, I use the sideways U. So a sideways U means subset, which means that there's some numbers and there's a subset. So we're going to look at an example. If I have C, 1, 2, 3, 4, and D, 3, 4, 5, if you read this, it says 3, 5 is a subset of D. To know if that's true or false, you should go to D and say, okay, is 3 and 5 in D? Yes, then it's a subset of D. Similarly, I could say 1, 3 is a subset of C because 1 and 3 are both in C. What you have to be careful of is the true false. If I said 6, 7 is a subset of C, there's no 6 and no 7 in C, so that would be false. So for a subset, you just need to make sure that the items listed before the sideways U are actually in the set. Now the complement is kind of an easy one. It's got a weird notation. It's got that little C at the top. And a complement just means who is not there. So what is not included in the list. So if I have D as 3, 4, 5, find the complement of D when U equals 1, 2, 3, 4, 5, 6, 7. Now when we're finding the complement, we're typically using a universal set. So what I'm doing is I'm comparing D to U. So I want to know what items are not in D, but are located in U. So to do that, I'm going to say, okay, I don't have 3/4/5. I cross them out. That's how I do these. And so I have 1, 2, 6, and 7. So to find the complement, you're using two different sets, and you're being asked what is not in one set that is in another. So another question, because we have some like this in the application problems, these are multi-step problems. They want me to find the complement of D, or what is not in D, and they want me to find the intersection of set E. So they've given me 3 sets here, and they said treat C as a universal set. So when I treat C as universal, that means D complement is the things that are in C but not in D. So I get 1 and 2 are in C, but not located in D. Once I have that, then I want to find where does this subset intersect E. And remember, intersect means what they have in common. So I have a 1 and a 2, and D has 1, 3, and 5. The only thing they have in common is the number 1. So the answer to the full question here, the multi-step question, is just going to be 1. So whenever you're doing these problems, you're going to work left to right, and you're going to follow order of operations. If something's in parentheses, you do that step first. And a lot of times we're going to whittle down to smaller and smaller items. Now, cardinality is a very large word, but it just means to count. A cardinality means you're counting the number of things that are in a set. I'm counting the elements. So if I'm given C as 1, 2, 3, 4, the cardinality is 4 because I can count there are 4 elements. If I want to find the cardinality of C intersect E, I first have to find C intersect E. So what does C have in common with E? If I look at what C and E have in common, C has a 1, E has a 1. C has a 2, but E does not have a 2. So I don't have that one. So I'm crossing out. C has a 3, E has a 3. C has a 4, E does not have a 4. And then we have a 5 in E, but no 5 in C. So there's my intersection, which is 1 and 3. How many items are in there? There are 2 items. Now, if I wanted to find C union E, that would be the things that are in both sets. So I would have 1, 2, 3, 4, 5. There are 1, 2, 3, 4, 5 items, so my cardinality of C union E is 5. So you're just counting the number of elements that are in each of those for cardinality. As you're working through your problem set, take your time this week. Post in the question thread if you need additional explanation, but this should have really given you a very good background on the sets. For help with the Venn diagrams, definitely go back and watch the first announcement video for the week on problem solving with Venn diagrams. As always, in an online math course, you have to participate. You have to reach out. You have to ask questions, because I'm not there to see the expressions on your face or to understand what you're not understanding. So in an online math course, it is your responsibility to post the questions that you have and to reach out as you need help. Definitely use the weekly question thread for that. While I can't tell you, yes, your answer is right, no, your answer is wrong, I can definitely guide you and create a video with a similar example to help you. You also have tutor.com. That is live one-on-one tutoring, just like you were in a classroom. Please feel free to take advantage of that as well. The tutors are very knowledgeable and they do know the material.